Many people in North America consider air conditioning in their car a necessity. In fact, 80% of all new cars produced on this continent are equipped with air conditioning, and over 80 million car owners enjoy the comforts it provides. This program will help you open the door to higher profits through quality repairs in the specialized field of automotive air conditioning.
We'll start the program with a quick review of air conditioning fundamentals. Then we'll introduce you to recent changes in the air conditioning system. Next, we'll perform a function test. This will help us determine which parts of the system are malfunctioning. And finally, we'll cover the diagnosis and pinpointing of a variety of problems.
This program is directed at those mechanics who have some experience in the air conditioning field. However, a brief review of the basic principles will assist those less familiar with the system.
Air conditioning is achieved through the characteristics of the refrigerant R12, which boils or turns to vapor at a relatively low temperature. The three major components in the system are the evaporator, the compressor, and the condenser. The system is charged with a predetermined amount of R12 refrigerant. Freon, in liquid form, is passed through the refrigerant tubes of the evaporator. When air is forced past the fins of these tubes, the R12 absorbs some of the heat from the air. In the process, the liquid refrigerant is changed to vapor, and the air serves to cool the passenger compartment of the vehicle. The vapor is then drawn in by the compressor, where it is compressed. This increases the temperature of the refrigerant to a point substantially higher than that of the outside air. It now passes through the condenser. Outside air, forced past the condenser fins, removes much of the heat from the refrigerant, changing it back into a liquid. The liquid R12 now passes into the evaporator, and the cycle begins again. To exercise some control over the amount of refrigerant entering the evaporator, a refrigerant flow control valve, sometimes referred to as an expansion valve, is introduced. The pilot-operated absolute, or POA valve, is used to prevent icing of the evaporator. The receiver dryer is a reservoir used to store liquid R12. It also absorbs and retains moisture from the refrigerant and acts as a filter.
In 1976, Ford and General Motors simplified the system by eliminating many of the moving parts. This helped improve fuel economy and accommodate smaller engines now used on downsized cars.
The expansion valve was replaced by a fixed orifice tube. The POA valve was replaced by a pressure switch, or a thermostatic switch, designed to cycle the compressor clutch on and off to prevent icing of the evaporator. The receiver dryer was replaced by an accumulator placed on the low pressure side of the system. Before working on an air conditioning system, make sure that you obtain an accurate description of the complaint from the customer. The next step is to perform a function test. That is, to check all phases of the system to determine if the complaint is legitimate. The service area should be well ventilated, and the ambient temperature should be at least 70 degrees Fahrenheit. To perform the function test, start the engine and let it idle for 5 to 10 minutes to allow the system to stabilize. Move the control through each mode with the blower on high. Place your hand over each related air vent and check the temperature and volume of the air. End your test in the AC maximum mode and with the temperature control in the cold position. Place a thermometer in the right center vent. If the system is operating normally, the temperature at the vent will be 40 to 45 degrees Fahrenheit, provided the ambient temperature is 70 degrees Fahrenheit and the humidity is relatively low. As a general rule, on a good system, the air duct temperature will be 30 degrees Fahrenheit less than the ambient temperature. This functional test will tell you if the problem is related to the vacuum system, the electrical system, or the refrigeration system. If the problem appears to be related to the refrigeration system, the next step is to perform a quick visual inspection under the hood. Check for foreign materials blocking the airflow through the condenser or the evaporator. Make sure the cooling system is in good working order. Inspect the heating and air conditioning electrical wiring. Look for loose or defective vacuum hoses. Ensure that the air conditioning hoses are properly routed and inspect for refrigerant oil leaks. A slipping or defective drive belt is also a common problem. Check the fan clutch. This one has a loose bearing and a fluid leak and therefore should be replaced. Having completed the visual inspection, connect a manifold gauge set to the proper charging ports and bleed the air from the lines. The pressure reading should be equivalent to the ambient temperature reading, in this case 70 degrees Fahrenheit. This means that there is sufficient refrigerant in the system to make the test. If the pressure readings are below that of the ambient temperature, then the system is low on refrigerant. Re-examine the system for leaks and loose connections, which could explain the loss of refrigerant. After correcting these conditions, or if no leaks are detected, add refrigerant as necessary before making further tests.
The next step is to measure the efficiency of the refrigeration system at ambient temperature.
Start by placing a high-volume fan in front of the vehicle to simulate the ram air effect of the air being forced through the condenser. Place a thermometer 2 to 4 inches in front of the condenser to read ambient temperature. Start the engine and let it run for 5 to 10 minutes to stabilize the system. Read the high pressure gauge. The proper gauge reading at average humidity can be determined by taking the ambient temperature and cross-referencing this reading to the pressure scale on the chart.